Geometry Chapter 7, Lesson 1. Now that we've looked at ratios and we've looked at proportions and we know a property of proportion, the fact that the product of the extremes is equal to the product of the means, let's apply that now to some proportions and see how that can help us solve for missing values in the proportion. So the way to do that is that I'm just going to do a number of examples. And we're just going to continue to use the fact that we know that the product of the means is equal to the product of the extremes, or the product of the extremes equals the product of the means. So let me write that. Let's write up here my name here. That the product of the extremes, so if I multiply the two extremes, that's going to equal the product of the means, and that is true of every proportion. So we're going to use that in order to solve for the missing value. So if we're looking at number 1 here, I know that the product of the extremes is equal to the product of the means. I identify this as a proportion. Therefore, I simply multiply the extremes, which is going to be 48, and that should equal the product of the means, which is 5 times k, and then I simply solve for k. So k is 48 divided by 5. Now I want you to take note here. I do not want these changed into a decimal for our purposes right now when you're just solving a problem like this. Okay, we want to go ahead and just leave it as an improper fraction. Changing it to its decimal is not a simplified version, so you're not doing anything as far as simplifying. Changing it to a mixed number does not simplify it, it just changes the form. So we're not doing anything by doing that. So when you're just solving these proportions, just go ahead and leave the fractions as they are. The only thing you have to do would be to reduce the fractions if they could be reduced once you finish, okay? But I want you to go ahead and leave it. The only time we would change this to a decimal would be if we're applying it to a word problem where we're actually determining the measure of something or the length of some item. In that case, the decimal answer or the mixed number answer is more appropriate, because in that scenario you'll want to do that. If we're giving the length of a picture, we wouldn't say the picture is 48 over 5 inches in length. No, we would want to say, well, that's 9.5 inches or 9 2/5 of an inch or whatever that would be. The decimal or the mixed number is appropriate in that situation. But when we're just practicing our mathematical skills, changing it to a decimal and changing it to a mixed number is not something we need to do. Additionally, this will help strengthen our ability to work with fractions. If we learn to get used to seeing them, get used to using them, it's really going to help in the long run. And working with fractions, believe it or not, is much easier than working with decimals. All right? And I don't have time to show you now, but just trust me on that, and we'll talk about that. We'll continue to talk about that in class. So as we look at number 2, I recognize this as a proportion, one ratio equal to another, so I can apply this property. So the product of the extremes, so 9 times 3n is 27n, is equal to the product of the means, 21. So n would be equal to 21 over 27. Now both of these numbers are divisible by 3, so I reduce that by dividing by 3, so I get my answer of 7/9. Alright, let's do a couple more examples. So we look at number 3 here. Again, I recognize this as a proportion, so I can apply the property here that the product of the extremes is equal to the product of the means. 8 times a is 8a, 9 times 3 is 27. I simply divide by 8, that's 27 divided by 8. That does not simplify, so that would be my final answer. As we look at number 4 here, there's a couple of things that I want you to be very aware of, because this is where most students will make their mistakes if they're not paying attention to the details. And you see here that we do have a proportion. I have one ratio set equal to another, but I have a couple things going on here that I want you to see. First of all, I have an expression, a plus sign or a minus sign in the numerator here. And what I would like you to do is to put a parenthesis around that, because I want you to recognize that this is one number. And so if you do not multiply this 5 times both parts of the number, then you're going to have an incorrect answer. It would be much like if you had this proportion, let's say 24 and whatever, doesn't matter, and you had 5 here, and you're going to multiply the 5 times the 24. If you multiply the 5 times the 2 and get 10 and then just leave the 4, well, that would be incorrect because you didn't multiply the 5 times the 4 as well as the 2 or the 20s. You have to do both. And it's the same thing when you have this minus sign or plus sign. Most students, if they don't write that there, will multiply the 5 times the p and then forget to multiply it by the 9. So the way to help remember that is whenever you see a fraction that has an addition sign or a plus sign or a minus sign in one of the numerators or denominators, is to put a parentheses around it. That way, when you go to mathematically do something to it, you won't forget. So remember to do that. The second thing I want you to notice is that this fraction is negative. Now, what does that mean? Well, let me tell you what it does not mean. It does not mean that the 9 is negative and the 5 is negative. It does not mean that. Why does it not mean that? Well, you remember if we multiply two negatives, we get a positive answer. And that same rule applies for division. A negative 9 divided by a negative 5 is a positive answer. So in actuality, whenever you see a fraction that is negative, what that means is that one of the two values is negative. It's either negative 9 and a positive 5, or a positive 9 and a negative 5. It doesn't matter which one is positive and which one is negative, but it does matter that only one is negative. Okay? So when you come to this situation, you have to decide which one of these two values you want to make negative and which one you want to make positive. It doesn't matter, so just choose the one you want. Now for me, because I see that 5 is going to be distributed to both of these numbers, I'd rather keep that a positive, so I'm going to make the 9 negative for my case, just so I kind of mentally do that. So now I can apply my property that the extremes, which would be 5 times this p minus 9, is equal to the product of the means, so that would be negative 72. So then I can go ahead and just do the arithmetic from here. Okay, so 5p and then 45 minus 72, 55, 65, that's 27. So this is negative 27, and then I divide by 5. For p is negative 27 over 5. Now you'll notice the negative is at the 27 and the 5 is positive, but that makes the entire fraction negative, again, as long as one is negative and one is positive. So a couple things to remember going on there. Make sure that you recognize that anytime you have an addition or subtraction in a numerator or denominator, you want to consider that as one value. I would highly recommend that you put a parenthesis around that to remind you of that fact. And the second thing to remember is that when you have a negative fraction, only one of the values is negative, the numerator or the denominator, and the choice is yours. It doesn't matter, just as long as you make sure that only one is negative. Okay, so let's do a couple more examples maybe that are along that line where we have a couple things going on. For number 5 here, I see this addition or minus sign in the denominator, so I'm going to put a parenthesis around that to remind me. So the 8 times the 5 is 40, and that's going to equal the 4 times the x minus 3. So we'll go ahead and distribute. It's 4x minus 12. We'll add 12 to both sides. And so x is going to go into that 13 times, so I have a value of 13. All right, number 6. Again, I see this going on, so I'm going to put parentheses around it. So I have 2, the extremes, times n minus 5 is equal to the product of the means, 4 times 12. I'm going to distribute. That's 10, that's 48. 2, we're going to, oops, that's an n. One more. 2n is equal to 58. So n would be equal to 29. Now you'll notice that these answers are in decimal form, but I'm going to leave them in fraction form. And again, I want you to leave them in fraction form when you do them. So I have two things going on here, so I want to make sure I put parentheses around both of those. And then the product of the extremes, so this is 4 times r plus 6 is equal to the means, product, r plus 3. So I just have two distributive things to do here. So 4r plus 24, 12r plus 36. So I'm going to move the 4 over here so I keep the r positive. So that's going to be 8r. And I'm going to move the 36 over here, so that's going to be negative 12. So r is going to be negative 12. Oops, got a little glitch in the computer there. Negative 12 over 8. And then dividing both by 4 is going to be negative 3 halves, which is 1 1/2. Okay, so let's go ahead and leave it as a fraction there. All right, let's do a couple more here. I got a couple more. So look at number 8 here. Again, I see I've got a couple of addition things going on, subtraction. So I'm going to put parentheses to remind me that I need to distribute that to both. Product of the extremes is equal to the product of the means. So then we'll just distribute. And then I'm going to move the x over here so it stays positive. And I'll move this over here as negative 122. Okay, and so x is equal to negative 122 over 8. Both of those are divisible by 2. So that's negative 61 over 4, which is, again, negative 15 1/4. But I want to leave it in a fraction form. All right, I have one more that I'll do down here, number 9, just so you have one more look at what you want to do. So again, I have addition and subtraction, so I'm going to put parentheses around those to make sure I remind myself when I multiply the extremes, I will distribute that. And then the means, so I've got 12 times m minus 8. So distribute 12m minus, let's see, 96. And again, I'm going to move the m over here so it stays positive. And I'm going to add 96 over here. 24 from 96 is going to be 72. And then divided by 10 is 72 over 10. Both of those are divisible by, let's see, 2. So that's going to be 36 over 5. And again, that's the same as 7.2, but I prefer the fraction. Okay, so we can apply those product of the extremes equal product of the means property to any proportion. All we have to do is be careful of our arithmetic when we do those, and that's pretty much all there is to it.